This is number 11, the very last one in the webassign, chapter 3, part 3. It talks about a golf ball with an initial speed of this much lands exactly so many meters downrange on a level course, right? Neglecting air friction, what two projection angles would achieve the result? Get theta 1 and theta 2, and what's the maximum height reached by the ball using the two angles? Right. So the clue here is level course. So when it says it's level course, we've got that special case that we talked about in class where y initial is same as y final, right? Initial level is same as the final level, or it's the same thing as saying there is no vertical displacement, right? So my picture would be, I could say, okay, if the golf ball goes with at some angle, it's going to take a certain, it's going to take some time in the air, and then you have a certain horizontal range. But we know for the special case we have seen that there are two angles, that the two are complementary angles. The second one will go higher, but it would have the exact same horizontal range, right? So this was our delta x, which we had called r. And we had done some work. We had shown that the horizontal range can be written in terms of the initial speed and the angle theta. And we had written down the range as, this came from one of the projectile motion equations, that horizontal displacement is horizontal velocity times time of flight. But we were able to write it in this form, vi squared times sine of 2 theta divided by g. I just want to remind ourselves that the vi here is the initial speed of the ball, not the x or the y component, but it's the magnitude of the velocity vector, initial velocity vector, times sine of 2 times this angle, and g is 9.8 without the minus sign, because minus sign was already absorbed in the equation, right? So what's given here is my r. R is 50.5, that's given. And sorry, that's not r. R is 245 meters, that's given. And the speed is 50.5, that's the vi. And g is 9.8, so you just have to substitute in here to solve for 2 theta, and then you can get theta from there. Okay, so if I just rewrite the range formula for sine of 2 theta, it's r times g over vi squared, where r and vi are given to me. And if I substitute those, I get something like this. So I can write down 2 theta as the inverse sine of everything that's here. So all of that stuff here. And if I calculate it, sine inverse of that comes out to be 70.301 degrees. Okay, so that's 2 times theta. So if I divide both sides by 2, my theta comes out to be 35.1505 degrees. Right. So I'll simplify this as 35.2 degrees. So that's one of the angles that gives me this range of 245 meters. So that's one angle. And the second angle is its complementary angle, which is 90 minus 35.2. And that's my 54.8 degrees. So these are the two angles which have the same range of 245 meters. Second part, they ask us what's the maximum height given these two angles. It's clear that whichever has the larger angle. So this was the one that had the 54.8 degrees. That's going to go much higher than the one that had the 35.2 degrees. So we'll just go ahead and calculate max height for this. And like for any max height problem, you recognize that the velocity at the top is only in the horizontal direction. So v final y is 0 at the very top, whereas you do have an x velocity which is the same as the x velocity here, right? So this is the problem we are looking at, and how high it goes depends on how much the y component vfy, viy is in the beginning, right? So given the velocity vi, the initial speed, you can get the vertical component. It's vi sine theta, and with the theta in there, we see that the y component is 41 point something, so millimeters per second. And then you can look at for max height. It's always easiest to use the last equation that doesn't have the time in it. At the very top, final velocity is 0, and we have done this many times in class. So you can write down the max height as viy squared by 2g. Substitute for your viy and g, and when you calculate it, h max comes out to be 86.881 meters. So if I'm rounding it to 3 significant figures, it will be 86.9 meters. Ideally, it should be written as 87 meters since there's only 2 significant figures in the problem.